Today we're going to compress a lot in. We're going to look at 5 different formulas. Now the nice thing about this is they're so similar that we're just showing you examples of different things. So we're going to look at volumes of prisms, cylinders, pyramids, and cones. So what's nice about this, there's no slant height to have to be dealt with. There's no crazy complication. It's actually very, very straightforward. So for a prism and a cylinder, the volume is fairly straightforward. It's capital B times H. And capital B just means capital B is the area of the base. If you determine that the base is a square, then use area of a square formula. If the base is the circle, then you're going to use the area of a circle. And next, of course, the H means the height of the solid. Another thing to consider is that B is going to be perpendicular to H. Specifically, there is no specific one for prism because prism, whatever the base is, it's going to change. So here we're just going to stick with BH, capital B times H. However, for cylinder, we have the volume for a cylinder specifically because the area of the base is always a circle. So pi r squared H will always be the formula there. A very intriguing thing about pyramids and cones is that the volume is exactly a third of the corresponding prism or cylinder. So the volume here, again, is just 1/3 of BH. And here, specifically, though, I can say it's going to be 1/3 pi r squared H. And the easiest one is cube, and the volume is just the side. My apologies, the S, that's not a 5. S cubed. And S is equal to a side length. Our first example is that we're going to find the volume of the cube, and this is so very straightforward. It's going to be so simple. You just cube the side here. So it's going to be 4 cubed, and in the answer therefore is 64 cubic inches, and we're done. No big deal. Whoop, whoop. All right, next up, the volume of each prism. Now this one, of course, let's start with our formula so we know what we're doing. Capital B is the area of a base and height. Here's the key about height. Height is the distance between the bases. So my base here is not the bottom, but my base is this triangle in the front, and the other base is the triangle in the back. So to find out the area of the base, I have to use a formula for triangle area. 1/2 length times width, or base times height if you prefer that one. So this one's fairly straightforward. And L is either 6 or 4, and then W is the other one.
Could be H as well?
Yep. If you don't prefer to just break this up piece by piece, you can do the whole thing like this. Volume is equal to 1/2 length times width, and then times the height, which is 1. So I just plugged it all into one formula. This is the area of the base, and that's my height. And when we finish this up, 1/2 of 6 is 3, and so we end up with 12 cubic feet. In this problem, this trapezoid, because remember, bases have to be parallel and congruent, and the only pair of shapes that fit that is the trapezoid in the front and the back. So capital B is 1/2 the sum of the bases times the height. Pause just a minute, and here's where things get confusing. This is the height of the trapezoid, not the height of the prism. So this here is H of prism. But this one here, the 6, is the H of the trapezoid. So it gets confusing at times. My apologies, but you just have to stay cleanly organized. All right, so now as I set this one up, the bases are 5 and 11 because this is parallel to this one here. And the height of the trapezoid is 6. So to finish up the area of the base here, and when we substitute in, we get 144 cubic inches. Let's continue. Now we're going to attack kill cylinders. Cylinders are very straightforward again. The volume is going to be pi r squared h. And don't forget that the h is the distance between the bases, the distance between the circle. So this right here is my h. And I can just substitute in. So pi, my r being 5.2. I'm going to square that puppy. And then multiply that by 9.8. So approximately 832.5 cubic centimeters. All right, your turn. Please attack, kill, destroy. What is the volume of this one right here? All right, now we are going to go on and find the volume of the pyramid. Now, the volume of the pyramid is 1/3 the volume of the area of the base times the height. Now, this is so very simple. We need to make the decision about what the area of the base is. I see that the base here is a square. So I can now say 8 squared there to find the area of the base. Now the height right here is 6. So I put the 6 right there where the h once was. And now I can begin to reduce right here. And I am going to get a number that looks like 128. Unit, oops, I have made a mistake. And there we have it in true Führer fashion. This one here is going to be, volume is 1/3 area of the base times height. Now, don't get into a rut. The base will not always be a square. It might be a triangle. It might be a rectangle. It might be something else. So you always have to pay attention. You might use a different formula down here. Okay, but for our purposes, the square, which is just a 6 by 6, so I put a 6 squared there. And then the height is 10 here. Now, thank you, 1/3. 36 times 10, and now I can reduce to get a 12 there. Do not reduce right here because this is inside and it has to be squared first. So it's not as straightforward. Don't just square this. Don't just reduce and then square. It's got to be square then reduce. So in the end, we get 120 cubic inches. All right, let's attack, kill, destroy the volume of the cone. Again, no big deal. 1/3 the area of the base, which is pi r squared, times the height. In this case, the height is h, and the radius is 3 millimeters. So all we have to do is substitute in.
75 cubic millimeters.
So 8 is there, and 3 goes there. Now, this one we can put in terms of pi and in terms of around it. So let me go ahead and keep going. 1/3 of pi times 9 times 8. I'm going to reduce here. So my exact answer is equals 24 pi millimeters cubed. And now the approximate value. Now, like we said earlier, if the coefficient on the pi were already decimalized, then go ahead and just go all the way to decimals. But in this case, I can have an exact answer and an approximate answer here.